What is Q? It is linear data. It follows first in first out FIFO principle. It has two pointers, front and rear. Here, the example of Q insertion at rear and deletion at front end. We are inserting the 5 elements: 10, 20, 30, 40, 50. If we try to insert still more elements to Q, it shows overflow. Q deleted and underflow. Step 1. Check if the Q is empty. Step 2. If the Q is empty, produce underflow error and exit. Step 3. If the Q is not empty, delete element from front position and increment front pointer to point the next space. Step 4. If front is greater than rear, make the initial condition. Step 5. Return success. Q delete and underflow. When front greater than rear, it results empty Q. Hence, we need to make initial condition as front equals 0 and rear equals -1 when front is greater than rear. If we still trying to delete the element from Q, it flow shows under. Disadvantages of linear Q. On deletion of an element from existing Q, front pointer is shifted to next position. This results into virtual deletion of an element. By doing so, memory space, which was occupied by the deleted element, is wasted. Hence, inefficient memory utilization is occurred. Overcome disadvantage of linear Q. To overcome disadvantage of linear Q, circular Q is used. We can solve this problem by joining the front and rear end of a Q to make the Q as a circular Q. Circular Q is a linear data structure. It follows FIFO principle. In circular Q, the last node is connected back to the first node to make a circle. Now, let us learn about circular Q. A circular Q is a linear data structure in which the operations are performed based on FIFO, first in first out principle, and the last position is connected back to the first position to make a circle. Why circular Q is used here? We can see an example. MQ insert operation on circular Q. Step 1. Check for 24. If rear equals max -1 and front equals 0, or if front equals rear +1, then circular Q is full and insertion operation is not possible. Otherwise, go to step 2. Step 2. Check position of rear pointer. If rear equals max -1, then set rear equals 0. Otherwise, increment rear by 1. Rear equals rear +1%. Max. Step 3. Insert element at the position pointer by rear pointer. Rear. Data. Step 4. Check the position of front pointer. If front equals -1, then set front as 0. Here, the example of circular Q. Delete operation on circular logic, useful in scenarios where operations mimic real-world systems like customer service lines or ticket counters. Third advantage is efficient resource management. Fourth advantage is dynamic handling. Advantages of CircularQ: 1. Efficient use of memory, in that we have no wasted space and avoids shifting to continuous operation, in that we have endless insertion and deletion and reduces leaking space. Fourth advantage is simplified implementation, in that we have circular nature and array-based design. Fifth advantage is performance improvements, in that we have reduced time complexity and predictable latency. That was a simple simulation of how and DQ of linear and circular cube works. Thank you so much for watching this small video.